In today's video, we're going to be going over the spiral matrix problem from homework 3. So, the prompt of this problem says that given a 2D end by end matrix, traverse the structure in a spiral and return an array representing the traversed values in order. So, if we look at this array, we have an example input. Essentially what a spiral is doing is we print out the first row, we print out the last column, we print out the last row, we print out the first column, but we don't include the first row anymore, and then we just keep on going inward and inward. So, to me, once I look at this problem, I have a rough idea what I'm doing, but if I struggle for, say, for like 5 minutes or so, which I should spend always like 5 or 10 minutes just thinking about the problem before coding, because if you just jump straight into coding, you might not, you might think you have the right answer, but you end up not, you end up wasting a lot of time trying to code a solution that would never have worked in the first place. So I would originally spend some time thinking about this problem, but if I wasn't able to solve and come up with what I think would be a valid solution in 5 minutes or so, I would not be afraid to Google this problem, which we always encourage you to do in this course. If you're not able to solve a problem, you should never be afraid to Google it on Wikipedia or LeetCode or one of many other sites. Because not only will they often provide you with the solution, they'll also provide you with an explanation of the algorithm they use to solve it, as I mentioned in the subset sum video. So you should never be afraid to Google. Google is your friend. It's here to help you. Make sure you use it. So when I look at this problem, I think I'm going to need to keep track of one thing. I'm going to have to keep track of a left bound on my row, and on my column, and a right bound on my column, an upper bound on my row, and an upper bound on my column, and a lower bound, on my row. Because first, I want to make sure, I'm just going to keep on moving my these bounds that I'm going to hold on my row and column. And then I'm just going to keep on shrinking the array when I solve this, because I never want, after I print out the first row, I never want to look at that first row again, so I can increment my lower bound. And then once I print out the last column, I never want to look at that last column again, so I can decrease my upper bound on my columns. So if we start coding this, I'm going to have if the matrix is none for length of my matrix 0. So that's just an error check at this point. So now I'm going to just copy these few lines, and I'm just going to keep on, as I write this solution out, I'm going to just show what I'm doing in this matrix here. Okay, so as I said, I want to keep track of the bounds, a lower and an upper bound for my row and a lower and upper bound for my column. So I'm going to have a start, row, 0, end, row, close. My matrix. And now notice that this is not actually going to be a valid row index. I'm going to have to do -1 anytime I try to access this. Next this. And this is just because I want to make sure, you'll see when I get to it, but I want to make sure that this is always going to be greater than my start row, because that means if they are the same, that means I've reached a point where I've already looked at the values. So I want to keep this above, and anytime I want to index this at this point, I should do this one. So now I'm going to have another one, which is like a left column, 0, and right column, which is the length of my matrix. And now, because I know it has at least length 1, I can do a matrix of 0, and it's a matrix, so it's not going to be jagged. It's going to be nice and clean. So I have these 4 variables now, and I'm going to have array, which is just an empty array, and I'm going to be returning array at the end of this method, and just for debugging purposes, I will print array. Okay, so now I can cap my loop. So I'm going to have just going to be one loop. It's just going to be a while loop. Actually, it's going to be several loops, but one big loop on the outside. And this is going to be, as I said, the reason I made these values instead of having them as -1 is because if it was only one row or one column, the start and end row would already start at the same, and so with the left and right column. So I always start at a greater. So then this loop is going to go from start row to my end row, and left column is less than right column. So I'm just going to keep on spiraling in until either one of these two conditions are broken. Yes. Okay. So now, the first thing I want to do is print out the first row. So this is just going to be, because I'm going to be iterating over columns at this point, I'm going to do 4j in range. My left column, right column, and I'm going to do array.append matrix and this is going to be my start row, my first row, which is my start row, and j. So at this point, I would have printed out these values here. And then now I never want to look at them again, so I'm going to do start row plus equals 1. And at this point, I can eliminate. Just for the purpose of this, I'm never going to look at these values again. Now, the next thing I want to do is I want to print out the last column here, so I can do for, now I'm going to iterating over rows, so for I in range, start row, end row. Now, because the for loop does not include the last element, I don't have to worry about an index out of bounds at this point because this is already 1 greater than my actual end index. So then I can do ret array dot append matrix. And as I said, this is going to be 1 greater, so since I'm putting out the right column, I want to do right column minus 1. Oh, sorry. Right column minus 1. And now I never want to look at this right column again, so I'm just going to do right column minus equals 1. Not indexes, but there we go. Now I feel like I've gone from J, O, T, Y. Okay. So we have now shrunken our array significantly. So now I want to do a quick check here. I want to do if. Now what I want to do is I want to go from my last row. On my last row, I want to go from my last column to my first column. So my right column to my left column. But because I've modified where my start row is, and I want to do another check now at this point to see if the start row is still less than my end row. And this is just an important check because I've modified the start row. And I just want to make sure that it still holds. This statement still holds. So now I want to do it for, and now I'm going to be iterating over columns because I'm going here. For J in range. And at this point, once again, as I had stated before, the right column had started off as 1 greater than the length of whatever I have left. So I needed to make sure I did, this is going, if I want to actually index it as I did with rows, I would have to do minus 1. So that's still going to be the case. So I'm going to have right column minus 1 because the right column value at minus 1 here has already been used up by something I've already removed from the array. So I want to make sure I do a minus 1 because, as I said, I'm always going to be, anytime I'm indexing my end row or my right column, I'm going to always do a minus 1. So then I'm going to do left column. I'm also going to do a minus 1 here because as Python works, it never includes the last element. So if I actually want the to index my left whatever is that left column, I need to go 1 beyond that, which is going to be minus 1. Now I'm going to go backwards. So I'm going to use -1. I'm going to do ret array dot append matrix end row minus 1, of course, and j. Now I can do end row minus 1. Now I would have effectively gotten rid of this last row, so I can get rid of this. Done. Okay. So now what I have left is I can. Okay. So now what I have left is this, and I want to go up this last column now. So once again, because I'm on my first column now, my left column, I want to do a quick check before I do anything. See if the left column is still less than my right column because I modified right column up here. Now, because I'm iterating over rows, I'm going to do for I in range just to keep. Anytime I'm iterating over rows, I always do for I, and then anytime I'm iterating over columns, I do for j. So here, now I want to make this. So I want to do matrix. Set up I, and I want to use my left column. Correct. Yes, whatever's in my left column. Oh, sorry. All right, binary. So now, once again, I'm going from. I'm sorry. I was trying to combine statements here. I was trying to do whatever I'm appending. So I'm going to go from my last row. Once again, I have to do -1, as always, anytime I'm going with these greater bounds. So end row -1, start row -1 is, of course, because I have to go 1 past it in order to include that index. Do -1. Alright, now I can do ret array dot append. Now I can have that statement here. So matrix row sub I, and then I want to use my left column. So I don't have to do a -1 there. I'm only doing -1 on my right columns and my end rows. So this should work. And then now I feel pretty confident in saying I can increment my left column because I no longer want to look at these values. And now I'm back to the situation here where I want to print out the first row, print out the last column. So I've effectively shrunken my array, and I can just enter the top of the while loop and just keep on going all the way around. So I have a test suite here. I'm going to save this here. I have a test suite, so I'm just going to run these tests. And all my tests pass. So it's good. All my tests pass. Yeah. Okay. So once again, hopefully you guys understand this. If you guys found this video helpful, leave some feedback on this video on YouTube.